me. Are there 2 number 5s on homework 4? I think I forgot my numbering didn't reset, or is there just, oh, okay. There's just 1 number 5. You're talking about this one at the end, right?
Yeah.
So the first thing we got to do is get this into standard form. So we'll FOIL this out. So 2x times 3x is 6x squared. And then 2x times negative 7 is negative 14x. 2x times, 3x times 1 is 3x, and 1 times 7 is, or negative 7 is negative 7. And we'll combine our like terms here. So there's that. Now we'll start the completing the square process. So we'll start by factoring out that greatest common factor of 6. Okay, there. And then I'm going to add and subtract 11 over 6 divided by 2 squared. So 11 over 6 divided by 2 is 11 over 12. Okay with that? And I'll then distribute the 6 through to kick those last 2 pieces out. And I'm not going to bother multiplying out 11 over 12 here, because I'm just going to factor in a second. I don't need it multiplied out to factor it. I do need it multiplied out over here, though, so I will do that. And then if I factor this, this is going to factor into x minus 11 over 6 divided by 2, and then the quantity squared. And 6 reduces here, and that becomes a 24. And then if I make a common denominator with the 7, 7 times 24 is 168, I think. And that's 289 over 24. And does that reduce at all? I don't think it does. I think that's probably as good as we can do. Does that feel okay? Yeah. Well, here's, I know it doesn't reduce any, because 2 doesn't go into it, into 289. And 3 doesn't go into 289, and those are the only prime factors of 24. So if those don't go in, it doesn't reduce. So I think that's as good as you can do. Does that feel okay?
Yeah, I just messed up.
Oh, sure. Easy to do that with all those fractions rattling around. But I think I got it right. If anybody noticed anything funny, please let me know. But I think I did that okay. Amy? Sure. Jack, are you okay with me moving? Okay. All right, so I'm going to start by putting this into standard form. So we're going to have to FOIL this out. Amy, is it okay if I just do this to FOIL it out? Like I don't write out all the FOILing stuff, I just write the final. Okay. I figured you'd be okay with that, but I you know, you should ask before you just go ahead and assume something, right? So 9 minus 27 is negative 18. So I'm looking for 2 numbers that multiply to give me negative 18 and add to give me 6. Oh my goodness. Look what I did. How dumb am I? I had the 36 there and I turned it into a 27. Yeah, because I knew what was coming, apparently. I already did the 9 and the negative 36 to write the 27 there. Boy, oh boy, Mr. Kulik. That was a silly mistake. I was like, but two numbers don't do this. I thought I worked these all out. This one does, though. Two numbers that multiply to give me negative 27 and to give me positive 6 are 9 and negative 3. So if I factor this up, then I can take an x out and then a negative 3 out. And then I have the x plus 9 and the x minus 3. Is that okay, Amy? Sure, no problem. Who's next?
Mr. Floyd,
Yes, Sergio.
number 9 on homework 2.
Number 9 on homework 2.
I don't even know if it's possible or not. So
Okay. Not all of them were, so that's certainly a possibility. So we need two things that multiply to give us 9 times 16, which is 144, I think, and add to give us 12. Okay with that? Now, I know that the sum part here is pretty small relative to the multiplication part, right?
yeah,
And I've observed, having done this a bunch of times now, as you guys have also, that when the numbers are very far apart for the multiplication problem, the sum is very big. And the sum is smallest when the numbers are very close together for the multiplication problem, right? So the closest they could ever be together is when it's the same number, right? You buy that, Sergio? I think you muted yourself. I couldn't hear what you said.
yeah. Sorry, yeah.
That's okay. So in the case of 144, that's 12 and 12. And because that's still too big, I know that there's not going to be a pair of numbers that works. So rather than starting at the top and going exhaustively down, I started at like what I know the bottom is. And if the bottom didn't even work, nothing other than that is going to work. Does that make sense?
Yeah, that makes sense.
Okay. But yeah, it doesn't work. So you're right on in thinking that.
Okay.
Loretta, on the same sheet? Sure. Yeah, you can say there's no two such numbers, or yeah, that would be fine. Okay. So Loretta will start the same way. We're going to look for two numbers that multiply to give us positive 80 and add to give us negative 8. Oh my goodness. Let's do something before that. Look at these coefficients. 4, 8, 20. They all have a greatest common factor of 4. Let's do that to start with. Oops. And that'll make our life a little bit easier because all the numbers now all of a sudden get way smaller, right? That's a time saver there. So I'm just looking for two numbers that multiply to give me 5 and add to give me negative 2. That's easy. There isn't any. So this is as good as you could do. You just take the 4 out and that's it. Cool? You guys are doing a good job on homing in on all the ones that just don't work out, right? Amy. Yep, I think it's a similar thing here going on. So if you look at the coefficients 15, 12, and negative 72, they all have a 3 in them. So let's take that out to start. Again, whenever you can do that, it just makes life ever so much easier. What's 3 goes into, that's 14, I think. Okay, so multiplying to get 5 times negative 14 is negative 70, negative 4. So we'll play the same game here and try to go as close together as possible. So the closest together pair of numbers that multiplies to give us negative 70 is 7 and 10, or one of them has to be negative. So we got to multiply to give negative 70, add to give negative 4. So negative 10 and 7 gets us negative 3. That doesn't work. And obviously the reverse isn't going to work either. After that, we could do 5 and 14, I think, is the next one. And that's now too small. And at this point, since there's no factors in between negative 10 and 7 and negative 14 and 5, I know I'm done. Because I've got one that's too big and one that's too small. That this isn't any better factorable than what we got here, so that's as good as we could do. Is that okay with you? Sure. Are you okay with how I figured out how I didn't have to worry about 11, 12, or 13 so quickly? Okay. Edmund?
Can you do something like that?
Sure. So here we're looking for two things that multiply to give us negative 4 and add to give us 0, right? Since there's no middle term. So those two numbers have to be 2 and negative 2. So this becomes 4x squared plus 2x plus negative 2x minus 1. From the first group we can take out a 2x. And from the second group we can take out a negative 1. And that gives us 2x plus 1 and 2x minus 1. Does that feel okay? Good. So the 0 part was probably the, what the heck do I do with that, right? But after you make that realization, it's like, oh, okay, I can find those two numbers. That wasn't too bad. Yeah, go ahead.
I also have a general question. So say, like, for line 2, say 2x and negative 1 were both negative 1, per se. Or they're both x. So will that be 2x or x squared?
Okay. So we'll do a little aside here, right? Because this is a hypothetical.
Sure.
Okay, now tell me exactly what to write.
So say it's x times 2x plus 1 minus x.
Okay, x times 2x plus 1 minus x times 2x plus 1. So that wouldn't really have happened because you would have had, at the step before, you'd had 2x squared plus x minus 2x squared minus x, which is 0. So like...
So what if the negative sign is positive?
Well, you shouldn't have variables in both of these. Is what it really boils down to for this kind of a problem. Now you could have had like something like this, where the first step you take an x out. Oops. You know, like if you didn't do that at the first step, then maybe you could have x squareds and x's, but you should never have two variables of the same degree at that step. Does that feel good? Okay. Okay, Amy. $15 on homework 1. Oh, okay. All you do is that and just distribute out. You're welcome. Those are my favorite ones to answer, the ones that are like, oh, I don't have to worry about trying to like think on this one too hard. I know exactly what to do. But it's so simple, it makes you second guess yourself, right? Totally okay to ask about stuff. Good. Last chance here. Okay, sounds good. Today, we're going to continue talking about factoring. But today we're going to talk about the factoring shortcuts. So those of you that have done factoring before and are like, I know a faster way to do some of these things, good. From here on out, everybody's going to get to use these shortcuts unless I tell you explicitly like not to do that. But I don't think I really would from here on out. I would just give you problems where you couldn't do the shortcut on if I wanted to see you not use the shortcut kind of thing. Okay. So we have a couple situations. So let's say we have a standard form quadratic where c is equal to 0. That'd be something, for example, like 3x squared plus 5x. All you can do is a greatest common factor here. So that's all that we can do in a situation like that. Okay there? Hopefully that feels pretty obvious. It's like, well, I didn't really need you to tell me that. Well, you know. So the second shortcut situation is where we have a standard form quadratic where the b value is 0 and the a coefficient is a perfect square and the c coefficient is a negative of a perfect square. So PS is just me abbreviating perfect square. So for example, well, I guess we should write this then. The rule. So Edmund asked about one of these in the previous homework. So I notice right away that a is 2 squared, c is 1 squared, and there's a subtraction symbol in between the two of them. Everybody okay with that? So immediately I can say this is just 2x plus 1, 2x minus 1. About 25x squared minus 36. What does that turn into then? It's the square root of 25 plus the square root of 36, and then square root of 25 minus the square root of 36. I forgot to say x in there, but everybody okay with that? The place that we have to be real careful about is making sure that we have a negative there. This does not work if that's an addition symbol. Okay? I will try to trick you with that at least once in the future by giving you something that looks like you can use this shortcut on, but I put a plus sign there instead of a minus. Okay? So be careful. I will try to trick you. I'm going to warn you in advance. Okay? The third situation is where we have a standard form polynomial where the leading coefficient is 1. So that means that if we can find the two numbers that multiply to give us a times c and add to give us b, we can take that straight to the factored form. We don't have to do the factor by grouping step at all. We can go straight to the factored form. Let's do an example of that, or a couple of examples of that. So here we need to find the two numbers that multiply to give us 12 and add to give us 7. Those two numbers are 4 and 3. So that tells me that this is x plus 4 times x plus 3. Or say this example, two numbers that got to multiply to give us negative 27 and add to give us negative 6. Those two numbers are negative 9 and positive 3. So that just becomes x minus 9, x plus 3. Pretty righteous, right? How much time does that save? Quite a bit, right? Now the stuff that we can't avoid, there's no good shortcut if A is not 1, B is not 0, and C is not 0. That's a situation where you're going to be using the long way. Unless, for example, you can take some greatest common factor out and turn it into one of these other situations. But is everybody okay with this idea? So from here on out, I'm encouraging you to use the shortcuts. You should do that. It's a very important set of skills to be able to do, and to be able to do quickly and effectively. Just a quick show of hands, who has used these shortcuts before in your Algebra 1 class? Okay, so a couple people. That's fine that you have. If you haven't, no big deal. I'm approaching this the way I would as if nobody had ever seen that before. So there's just two of us with a little bit of a head start, but we're going to be doing, the class will be approached as if none of us had done this before, since by and large the majority of you haven't, which is fine. The rest of our time today, we're going to spend doing some timed practice doing this. So this is a skill that we want to be able to do quickly and accurately. So we're going to take some time here in class today and do some timed factoring practices using these shortcuts to give you a chance to get used to this process, to get a little bit better, get a whole bunch of practice in a kind of a low stress setting where it's maybe a little bit more fun than just doing a boatload of problems. We make it mildly competitive, see if you can finish. It's a little bit more fun and interesting than like, here's 100 factoring problems, just go ahead and do this, right? Okay, so we're going to do 5 of these factoring practices. Those of you that are working from home, I'm going to dump these in the content library right now. Those of you that are with us here at school, you don't have to do anything because I have handouts for you guys. Those of you that are at home, if you're having trouble like getting things to sync up on time, do your best to follow along. But if you have to do yours like you're behind or whatever and you have to time yourself, no big deal. None of these things are going to be collected or graded or any of that. It's just kind of for fun and for practice, so you don't have to worry about that. We're just going to, at the end, I'll ask, like, for show of hands, how many got, this many finished, and then we'll give you the answers and ask how many got, this many correct, and we'll just kind of do a little quick show of hands for me, just to kind of see where we're at, how much practice we need, or if we're getting better with some more practice and all that kind of thing. So it's really informal. I'm not going to look at these ever. So they're yours to keep. There's no reason to fib about them, but if you wanted to fib about it, I guess you could. But so all you'll need here for the rest of our time is just a pencil, and if you want to use your calculator, you can. I wouldn't deny you that. You don't need it to do any of these problems, but if you want to use your calculator, you can. It's fine either way. But they're all things you can do without your calculator. Leave these spaced down until I tell you to flip, because we're going to do these timed. Where are the rest of my connections? Is this all going to be the same problem? Well, these ones feel thicker. Where did the rest of those go? Oh my goodness, Mr. Kulik. What is the matter with you today? Well, I don't know. It's just like... I don't know. You ever have one of those days where like everything is just screwed up? Apparently that's what's happening to me. So I'm going to go print some more. I'll be back in just a minute. So hang tight. Don't peek, you cheaters. All you're doing is cheating yourself. But I think the rest of these feel thick enough that I think I have enough for everybody. I don't know why this one was small. But whatever. We'll figure it out. It'll just be a minute. 12 more should do. There's no more 2 rows of 6. There's less than that filled. So back in about 15 seconds. I know. It's
It's not like the front yard is straight to the pile. Desire a whole pile on this side. Like, I'm in the playoffs. Year 20, year 3. And then it's so 13 and 14 seasons.
I switched after how lost it. I had to switch them on with this one. Now it's got some 5 stars. Yours was saying, like 5% fans and like half of the guys. I had to rebuild the whole team.
That's how we do it. I would play 7.
I'm bad. Longer than 15 seconds. Not much longer. Okay. So this first sheet is just, there's not actually any factoring on this one. So this first sheet is just like find the two numbers that multiplies to give you whatever and adds to give you whatever. That's all we have on the first sheet. There's 10 questions. They are all doable. We're going to take 4 minutes to finish this. And then we'll get a count of how many we were able to finish in that 4 minutes and go through the solution. Sound good? Okay. On your marks, get set, begin.